There it is. Are you printing it?
I'll get to it now.
Okay.
I had to restart the computer and it didn't want to do anything.
Oh,
I have to do that about every 2 or 3 months on the computer.
Now, are your pages, at least for a filled-in version of this thing is entirely garbled up?
The filled-in notes are garbled up. Well,
One of them is.
one of them, that's because that's the back of a page.
Okay.
What happens is the marker bleeds through, and then when I scan it, you go ahead.
Okay. So make sure that there wasn't
So if
anything.
you got a blank page in there, the scanner thought that was something that it wasn't. It was just the back of the page that had a few marks from the marker bleeding through.
Okay.
So,
Yeah, just wondered about that.
so. Okay, so we gotta, some of you that already retook test 1, this should be familiar. Sketch array, which is moved through 11 pi over 3. So, and I don't know about you, but there's not enough space here. So let's just, I'm just going to write another different piece of paper. So array, remember array, and we're going to start at the standard position. So here's our axis. Here's the beginning of the angle. And then we're going to move through 11 pi over 3. So you can either take 11 pi divided by 3 and subtract 2 pi, or you can start counting. I mean, I actually counted, but let's subtract 2 pi. 2 pi is 6 pi over 3. So 11 pi over 3 minus 6 pi over 3 is 5 pi over 3. And we can subtract another. No, we can't. Okay, that's it.
It's just 300 degrees.
Yeah, that's right. So we can count. It's one whole. In your sketch, you need to show this. It's one whole revolution, and then it goes to pi over 3, 2 pi over 3. Remember, this is 3 pi over 3. About over here is 4 pi over 3. So right here would be 5 pi over 3. So that's how you sketch a ray. You're drawing, you're making this ray go through 11 pi over 3 by doing a whole revolution and then 5 pi over 3 more. And then it asks you to label the reference angle. Okay, so in pi radians, so the reference angle is always the angle against the x-axis, the closest x-axis. And it's positive. Against the closest part of the x-axis. So that's this right here. This angle is pi over 3. That's the reference angle in form. Or you could take it, you could subtract. You could take 4 pi over 3 minus 11 pi over 3, or 2 pi. The reference angle you could find, just from the picture you can see you need to subtract 2 pi minus 5 pi over 3. And if you subtract the wrong way and get a negative number, just take the absolute value. And that's, so either way, but I like the picture. You see exactly what it is. So that's the reference angle.
Can we just label that as theta prime?
Yes, so if this would be our theta prime, that's what the notation we use for reference angle. And this is our 11 pi over 3. I can't write, oh, sorry. Theta, 11 pi over 3. Sorry, I made an extra mark there. So, if you want to use different colors, or you just want to, yeah, it'd be good to label it as theta prime. Or I'll have a blank for you to write the reference angle in, but I'm grading you on your sketch. It says sketch array.
So, for example, if we knew that whatever our ray was in the third quadrant as opposed to the fourth, you would instead take whatever that is and add pi to it to get your...
Yeah, right,
Okay.
exactly.
So you determine which quadrant it is to determine what you're adding or subtracting.
Right, it's just the angle against the closest part of the x-axis.
Okay.
So, yeah, and if you get a negative number when you add or subtract, you just got to take the absolute value. Because reference angles are positive. So a lot of you got messed up on reference angles when you got a -1 and then you were subtracting a negative and on that last test, I think, or test 3 or something. Test 3, not test 4, I haven't graded. Okay. All right, so did everybody understand what he asked? That if you have, so if we had, our angle was 4 pi over 3, then what's our reference angle? It's against this axis. It's, again, I need to make it positive, it's still pi over 3. Which, so if you don't want it, you don't have to show the work where you say, but that's theta prime. Theta prime was our reference angle. So you would find it by taking 4 pi over 3, 4 pi over 3 minus pi, because this whole thing is pi. A straight angle is pi. So, but you get the same thing. That's 3 pi over 3, 4 pi over 3 minus 3 pi. I like the picture, but you have to draw the picture. That's part of your thing that you have to draw the picture and draw it. So it's a good idea. Label it, please. Yes. All right. Okay, and draw and label the reference triangle. Okay, any questions on that one then? No? Okay, so we're going to draw and label that was number 1 with an extra example. Number 2, we want to draw and label the reference triangle. I'll just put for theta equals 210 degrees. And remember, this is the part where you don't have your unit circle and you don't have your calculator. So you've got to know, that this is pi over here. But here at 210, you've got to know that this is 90 degrees, this is 180, this is 270, and of course it's 360, 0, but so 210 is 30 degrees more than 180, so this is 210. The reference triangle is the triangle that you make right up here, perpendicular to the closest part of the x-axis. You do, so the reference angle, theta prime, is 30 degrees here. So this is kind of small, I don't know. Okay, so this is a 30, 60, 90. So let me make it a little bigger. Okay.
The two reference triangles we have are all the 30, 60, 90, the 45, 45, 45, right?
45, 45, 90, yeah.
90, okay.
And some of you, this is, did I make it big enough? 30. Some of you got mixed up between the 30 degree and the 60. The 30 degree is going to be the smaller one, and the 60, and it's always against the x-axis. So don't draw the triangle here, and if you get the wrong angle, you're going to get the wrong values. It's going to be mixed up, opposite. Cosine will be sine, and sine will be cosine for 30 and 60. So a 30-60 triangle, to remember that, is that the shorter side is 1/2 the radius, or the hypotenuse. I'm thinking of the unit circle, so 1/2. So if this is 1, then this is 2, and this is the square root of 3, or you could use the Pythagorean theorem to find that that's the square root of 3. But this is in quadrant 3, so we're going, x is negative here. So you do need your negative signs, and y is negative. But the radius is always positive, or the hypotenuse is positive. Okay, so you need your signs. Because we're in quadrant 3. And that's it. We've got this is our reference angle is 30 degrees, theta prime. So we've labeled the reference triangle for 210. Any questions about that? Now some of you, it's okay. Some of you love that unit circle, so you're drawing it like this. You do have to draw it in the quadrant it's at, and you're drawing it like this. Square root of 3 over 2 minus 1/2 and 1. This is 30. And that's okay. If you want to draw it like that, and so this point on the unit circle is minus square root of 3 over 2 minus 1/2.
Can you remind us what a standard 45, 45, 90 looks like, and what the x, y values?
Let's see, are we going to do that? Yeah, I can. I do that in number 5.
Okay, never mind then.
Okay? So this is actually, up here, this is the standard. 30, 60, 90 triangle. If you want to draw it with this, by dividing everything by 2, that was one of the worksheets I did. You can. It just makes it harder to find opposite over adjacent. It makes the calculation a little harder to have that over 2. I didn't take off on any of the tests if you drew it this way, it's okay. So this is okay. It's not the this is okay. It's not the standard 30, 60, 90. But it's okay if you draw it that way. You still get the same answers. Okay? All right. Okay, number 3. I just printed this out. Well, I can write on it now. All right. So this is the non-calculator part. Is cosine 225 positive or negative? So from what I just had drawn, you know, you gotta figure out what quadrant 225 is in. So this is 90, this is 180, this is 270. So it's in quadrant 3. So is cosine positive or negative in quadrant 3?
Negative.
Negative. And why is because it's in quadrant 3. That's all you have to say. The why doesn't have to be anything. Just tell me the quadrant it's in. Or you could say because it's cosine is x and x is negative, but no. You can just write the quadrant for the reason why. Okay, and so is sine of negative 3 pi over 4. Okay, so draw, I always draw a sketch. You know, this is negative pi over 2, if you're going this way, and this is negative pi. This is negative pi over 4, negative 2 pi over 4, negative 3 pi over 4.
Oh, that's pretty cool. 3 and 4 at the same point.
Oh, they are, aren't they? Is sine of that positive or negative? Negative, and it's because it's in quadrant 3. And it was the same angle. Those were coterminal angles. Okay. Then find the exact value of tangent of 3 pi over 4. So here's where I drew the picture. I'm going to draw a picture of the standard. So let's go to 3 pi over 4. And I'll just draw that picture, number 5. So this is 3 pi over 4. Actually, this angle. So the reference triangle is here. And the standard reference triangle would be 1, 1. And if you take 1 squared plus 1 squared and take the square root of that, you get the square root of 2. And because this is in quadrant 2, this is going to be negative here. So don't forget the sign. You're in quadrant 2, so x is negative. And so find the exact value of tangent of 3 pi over 4. This is our theta prime is pi over 4. So tangent of 3 pi over 4 is opposite over adjacent is 1 over negative 1. Negative 1. Okay.
I use the unit circle coordinates also.
Oh yeah, okay. And you can use, so just show that if you're using the unit circle coordinates, just write down
You guys show
that.
the math of like root 2 over 2, 32 over 2.
Yeah, you would do, yeah, so if you want to do it with the unit circle, you actually have negative square root of 2 over 2 square root of 2 over 2, right?
Yeah.
So this is 3 pi over 4. So if you're going to do that, this is cosine and sine, so tangent of 3 pi over 4 is sine, right, of 3 pi over 4 over cosine. And sine is square root of 2 over 2 and this is negative square root of 2 over 2, and you get negative 1. So again, this is the standard $45.90 triangle. And this, you'd have to divide each of these by the square root of 2. This would be the unit circle one. You have negative square root of 2 over 2, square root of 2 over 2, and 1. How do you get 1, a radius of 1, to make it the unit circle? You got to divide everything by the square root of 2. So that's how you get back and forth between those. So if you can't remember the standard, I will take this also, but it's a little more work. But if you like that way, or you like that way, don't you? Okay, so you should show like, at a minimum, show this. Show those steps. Because then I'll know you understood, right? I always have to, you guys always want to know the minimum number of steps, right? You don't want to write too many steps. I know you probably have this memorized, some of you, so, but just show, this is just one step in an answer, okay? But you will do better if you would draw, and I'd probably ask you to sketch it, so you do have to sketch the picture, okay? So either the standard I think the standard is a little easier to work with, to find all the, if you need to find trig functions, but either way. Any questions? That makes sense? You remembering it now?
Yeah.
Okay. Well, we've been using it all semester, so this course really, 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 really does use the beginning stuff all throughout the semester. So if you got off to a bad start and didn't understand the beginning stuff, then it's going to be a struggle. All right. Is everybody done? All right. So given number 6, given y equals 2 cosine of 4x plus pi, state the period. Okay, so you guys are going to have to memorize this. Let me write it down. Y equals a cosine of bx minus c. And because of the cosine function, the period is 2 pi divided by b. The period is equal to the period of the regular cosine x function divided by b. So if it's a tangent function, which I don't think I gave you that, so it'll be sine or cosine. So the reason though it's 2 pi is because it's the cosine function. It would be pi if it's tangent. Okay? The period is 2 pi over b. So we can find the period. We've got a 4 here. 2 pi over 4 is pi over 2. B is 4. Okay, so I've got a period of pi over 2. What's the phase shift? So you need to memorize that the phase shift is c over b. And we got it, so there's a bunch of things you have to memorize for this problem. The period of sine and cosine is 2 pi over b. The phase shift, and you have to memorize this. it has a minus sign there, the minus sign. Okay, so now we're gonna find the phase shift. C is negative pi. Can you see that?
Yeah.
Okay, so we got negative pi, and we just found B was pi over 2. So that's negative pi divided by pi over 2, or times 2 over pi, is negative 2. No, why did I say
Wouldn't it
that?
be negative pi over 4?
Yeah.
It should be. Why did I do that? What did I do? I have my phase shift as C over B. Huh? I don't know. C is,
You got your C right, it's the B. It's just 4, right?
B is just 4. I was putting the period in there, sorry. Still the notes are right. Okay.
Can we have a note card on this file?
No. So you do need to memorize this.
That's what I'm saying.
So be prepared to, have it memorized and download it. Onto your paper. Yes, you do have to memorize it. So maybe a good thing to do that I didn't do here is to identify what A, B, and C are. So A is 2, B is 4, and C is negative pi, and this would have helped me from making that mistake over here. So, all right, so now we got the phase shift is minus pi over 4. The domain, what's the domain of any cosine function? All real numbers or minus infinity to infinity. You can write all real numbers out, or you can write minus infinity to infinity. The range, well, what's the amplitude? 2. So it's gonna, we're not adding or subtracting a d here. So it's going to go between negative 2 and 2. So an interval notation, that's negative 2 to 2. And now you're going to sketch 2 waves of the function. So somewhere around here. Oh, well, let's sketch it. I didn't sketch it. Yes?
Is the amplitude just the absolute value of A?
Yes. Yeah, if I ask for the amplitude, good question. The amplitude equals the absolute value of A equals 2 in this problem. So we didn't ask for the amplitude. We might ask for the amplitude. All right, we're going to sketch 2 waves of the function. That means 2 periods. That's what we're going to be asking you things in this language, waves. Okay, because it kind of looks like a wave, doesn't it? 2 waves of the function. So all right, so we got cosine function. I guess okay, we're going to start with the phase shift, negative pi over 4. And then these are the 5 key points. And then I'm going to add the period divided by 4. So I've got to figure out the period. This is going to help me draw it. The period divided by 4. So you start with your phase shift. Since it's not 0, this is your phase shift. Period is pi over 2. Pi over 2 divided by 4 is times 1/4. Is pi over 8. because of the 4. You know, it's so the period over 4 is pi over 8. That's what we add to this. So the next x is going to be minus pi over 4 plus pi over 8. That's negative pi over 8. The next one is going to be add another pi over 8. The next key point is going to be 0 plus pi over 8. This is what we're adding. We're adding the period divided by 4. That's pi over 8. And then we add another pi over 8 to get the last one. That's pi over 4. So you're going to have a blank axis to draw this on. Okay, so what are we going to get? This is the cosine function. I don't know. The cosine function, remember, let me write this out over here. The cosine of x at 0, pi over 2, pi, 3 pi over 2, and 2 pi. The cosine function is at 1, 0, negative 1, 0, and 1. The regular cosine function, let's draw it. 0, let's see, 1, 2, 3, 4. This will be 2 pi. And if this is 1, make this 2. So the cosine function goes like that. Oh, sorry. That's the cosine function. Okay, so on this function we're taking, I mean, you can plug in minus pi over 4 and figure it out, but you're going to have 2 times 1. And this first, you got an amplitude of 2. This is going to be 2 times 1. This is 2 times 0. This is 2 times negative 1. This is 2 times 0 and 2 times 1. 2, 0, negative 2. This is one wave, or one period. 0 and 2.
Just do the amplitude times the...
So I'm taking the cosine times the amplitude because I know these are my 5 key points. These are the 5 key points of cosine. So, yeah, I did that. But you could also take your... Well, this is a non-calculator part, right? Whoops. Yeah. So I took the fact that cosine is 1 here. These are the 5 key points, the x value. At these points, just a plain cosine of 4x plus pi will be 1, 0, negative 1, 0, and 1. But now because they have an amplitude of 2, we're going to multiply it by 2. So this is where I got these. I got the 1 from here, the 0 from here, the negative 1 from here. These are the 5 key points in a regular cosine function. When I figure out my 5 key points by taking phase shift and then adding the period over 4 and getting my 5 x's, then I know all I'm doing is changing it times 2 here. So now I'm going to draw that, and we probably should have made it bigger chart, but this is at minus pi, okay, so this is pi, this is pi over 2, and this is 3 pi over 2. So minus pi over 2 will be here, minus pi over 4, pi over 4, 3 pi over 4, I'm having trouble fitting all this in. This is, well, let's just do, so,
Do you have to put those?
well, it's going to help me to have some of them in here. Okay, I'm going to go ahead at minus pi over 4, I'm up at 2. At minus pi over 8, which is halfway there, I'm at 0. At 0, I'm at minus 2. At pi over 8, geez, this is going to be, at pi over 8, I'm back at 0. And at pi over 4, I'm at 2. So it is not straight lines, but it's going to be hard to. And then it repeats itself. You need to do a second wave. It's going to be here, here, halfway between there and here. So the second wave. So, did my field and notes have a picture? No, I don't think so. Okay, so that was, so I didn't need more than that. I didn't need to fill in the minus pi over 8 and everything. So that's, we sketched 2 waves. There is a problem like this on the test, so practice it. You have to do it without your calculator. Or you can take a picture of my picture.
As soon as it is on here.
Or I can take a picture of it and post it and show me.
Picture of it, draw it later.
Yeah, do you want the picture of the whole thing? Or just
If you can, get it on there.
like this part?
I say remembering the parent functions for each.
Yeah.
You know what I mean?
Yeah, if you can remember, I have cosine and sine memorized. And I had not reviewed this since we went over chapter 1, so. like,
Yeah, but you do this almost every year, don't you?
no, my first time teaching this class was last year.
Well, see, but you're a pro.
I've become a pro last year.
But you've been teaching math
I've been teaching math a long time,
But you've
but
been teaching math for a long time, so picking up these things should be a bit easier for you.
it was. Last year was my first time teaching this class. It was a lot harder. This semester is like, okay. But I can improve though. Yes.
So how do we know what points to plot for the second wave of it?
Well, if you want to continue your little chart, you can, but I continued the pattern.
Okay. So we just,
I knew that the cosine is going to go down to here next, and there next, and there, and there. Cosine, you know, goes like that. But you could, if you want, you could keep adding pi over 8 to get your second wave. But so I knew the next, I'm at the top, I knew my next one, you know, these are the 5 key points in cosine. So I was at the top, so I went to the middle, and I knew that was difference of pi over 8. And then I went to the bottom and making sure I was only going by pi over 8. I had to go by pi over 8.
And for the Y key points, it's always going to be like the parent functions.
Times the amplitude.
Okay.
Yes. Or, it'll be, well, not just the amplitude, it'll be whatever A is, times A.
Okay.
So this is A.
So it's not the absolute value of A.
It's not the absolute value of A. In fact, it would be flipped if it was a negative. Okay? That's section 4.6. Yeah, that was a hard section.
Can't stand that chapter.
That test material, test 2 material. Yeah. So you had to take home test on this. Get your test out. Make sure you can do those problems too. Phase shift period, yeah. Right, okay. So are you done copying it? Okay.
I got a picture of it.
You got a picture of it? That's good. I can post a picture after class. But this was 1. This was number 6. And this was 1. All right, so number 7. Oh, let's see, where is
That's the sign.
that's finding an equation for.
I can give you the function. It's y equals 3 sine 1/2 x.
Oh yeah, here I have it. Okay, so here's the picture. The picture that we're talking about. So minus 2 pi pi, 2 pi, 3 pi, 4 pi, 5 pi. And then it went up to 1, 2, 3, negative 1, 2, 3. And so it was here, and then it was here, 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 here. So this was a picture. Oh, that's purple too. I was gonna do a different color. Picture. Okay. What does this right here look like? The sine wave. That's a sine. So this is the sine wave. So it's going to be a sine function. That's the easiest. The amplitude is 3. Y and A is 3. Because we're starting at 0 and it's a positive sign. It's just a sine wave. 3 sine. Okay, and 1 period for this thing equals 4 pi. So we got to solve for B. So we got a period of 4 pi, the amplitude is 3, A is 3, phase shift 0. So the period is equal to 2 pi over b. So we set that equal to 4 pi. So we're going to solve 2 pi over b equals 4 pi. Let's cross multiply, or we could multiply through by b. If I cross multiply, I get 4 pi b equals 2 pi and divide by 4 pi. B is a half. So there's our function. It wasn't flipped. So we want to start here. We see a regular sine wave starts here. So we can use the sine. There's no phase shift. The amplitude's 3. It's not inverted. It's not flipped. So we don't have a negative 3 for A. Okay, and I think, so, any questions? So you have to have these things memorized. 2 pi over b equals a period. You have to know the stuff I had boxed in on this page. You know, you have to know this stuff. The
Could you
cosine.
possibly add that to the
Let's see.
formula sheet?
There is an extra page of the formula sheet.
Does it include some of the formulas that we got from this last set, actually from our last test?
Oh my gosh, you're getting my brain.
I found it. Let me pull it up. I will post it too, but
That's what science is good. That's it.
thinking, okay. Part 2. So you get to have this. Let's see. I'm going to put it in Shelby right now. Connecting the printer, why? I just saved it. This is the extra formula sheet you get. So you get the one that you used for the test 3. You get this one. So that's what you get. So at least you don't have to memorize these things. So I'm going to post that in Shelby. So if I go into Shelby, so we actually didn't have time in one class period to do the whole final exam review, especially if we do it slow and make sure you understand it, so that's fine. So that's why it is good to have 2 days.
Yeah.
All right, so where's the, do I have chapter? Do I have a final? No? Have unit circled?
Don't have enough.
Should I just put it in the test 4 material?
Should we make a new thing?
A new folder?
Yeah, probably just better do that. That's not to confuse us
Oh, yeah.
later on.
Final, oh, that looks like I already have one.
Maybe for another class you did it?
Math 1720 formula sheet. this is part 2, and here's part 1. And then I have my review for final exam solution. And I usually don't even post the final review answers. I just like to put the whole solution. The review for final, I have to save it as a PDF. File, save as PDF. Now I can drag that. Whoops. Review for final. Oh, okay. I didn't realize you guys didn't have a final exam review folder. All right. So this is the formula sheet. It's got 2 pages. So it's got the law of sines. It's got Heron's triangle rule too, but we got that page. And then I'm going to give you this other page. But there's nothing on here. Yeah, you had to memorize that. This is the sheet 2. So this stuff, was the law of cosines down there? No, probably not. So this is a unit vector, the angle between 2 unit vectors, the conversion formulas, and then you're expected to use the conversion formulas instead of the shortcut I showed you with second angle. You can check your work with that. I showed you how to do it. But you'll get exact answers if it's square roots of 3, if it's and square roots of 2. But if it's not a 30 or 60 degree angle or 45 on these things, when you're converting, you're going to just round the decimal places. So, of course, if the directions are confusing, you should ask. I'm going to be looking over it and trying to make sure it's not confusing, but okay. So you do get to use that too. All right. All right, so now we're on, what, test 3 material? Is this test 3 yet?
We just got to the second page.
If tangent theta is -2/3 and cosine theta greater than 0. So tangent is less than 0 and cosine is greater than 0. Find the exact value of each of the remaining trig functions. So you're going to also sketch this. You want to sketch it. What quadrant is it in? Cosine's greater than 0. That's going to be quadrant 1 or 4. Tangent is less than 0. That's quadrant 4 or 2, but it's going to be 4. So we're in quadrant 4. Okay, tangent is opposite. -2/3, and I'm not sure, I think I have to move the minus sign. Oh no, I don't. Sorry. Let's write that again. Tangent is -2/3 is opposite over adjacent. Okay. And because we're in quadrant 4, so we're going to go, theta is going to be, let me draw, opposite is y, and this is going to be 1, 2, 3. This is my theta prime, my reference angle I'm going to use. Theta is actually here. But I can draw my reference triangle is positive 3 because it's positive x-axis, negative 2 because this is going down for y, and then I can find r, 3 squared plus minus 2 squared equals r squared. So that's 9 plus 4 equals r squared. R is square root of 13. R squared is 13, square root of 13. So r is the square root of 13. Now I can find all the remaining trig functions. So there's 4 left. So we can find sine of theta is opposite over hypotenuse. You're going to use theta prime. Negative 2 over square root of 13, but we want to rationalize that, so we take square root of 13 over square root of 13, and that is minus 2 square root of 13 over 13. Square root of 13 times square root of 13 is 13. What's, we already got cosine. What's 1 over cosine? No, we don't have cosine. Cosine, cosine. Cosine theta is adjacent over hypotenuse. Adjacent is 3 over the square root of 13. Hypotenuse. And that's 3 square root of 13 over 13. And then we have tangent, so cotangent is 1 over tangent. So cotangent theta is 1 over tangent theta. That means you just flip this, is minus 3 halves. And cosecant theta is 1 over sine theta, but we want to pick the sine theta before we rationalize it. Flip that. It's the square root of 13 over negative 2. Or you could have did, cosecant is hypotenuse over opposite, but I usually do it this way. Secant is 1 over
Cosine.
1 over cosine. So we don't want to flip this and mess with all of that simplified. We want to flip the unsimplified version. So we're going to flip this. Square root of 13 over 3. And it's already rationalized. So that's our 6 trig functions. So we draw our reference triangle, we make sure our signs are right, we find our radius, and then we can find all the other functions. And sorry it looks so messy now. I think I'll redo this and put more room in it for work so we don't have to crowd it so much. But all right, find the period and amplitude. So the period and amplitude are the following. So the amplitude of 1 times 2x, the amplitude is 1. So this will be the amplitude. The period is 2 pi over v. And v here is 2, so 2 pi over 2 is pi. amplitude is -2 here. Oh, the opposite, the absolute value. A is -2, the amplitude is the absolute value of A. Okay, so we do have to take, so that's why my key has a +2 written down, because I put a negative originally. All right, period. This is, B is pi now, so 2 pi over B, 2 pi over pi is 2. All right, now the only thing, the next question is, how would you draw cosecant? What would you sketch first? We're not going to draw a cosecant function on to draw these functions, and we didn't even cover the drawing them, because, except that I told you guys this, but it's been quite a while, you probably forgot. What's the one, cosecant is 1 over sine? So to sketch this, you're going to sketch first sine of x plus pi over 4. That's all. And then you would try to flip everything, and you know, and you don't have to do that on the test. Know which functions are continuous and discontinuous. So sine and cosine are continuous. The rest are discontinuous. Cosecant, secant, tangent, and cotangent. Okay, on a calculator in radian mode, the inverse sine of -pi/3 would provide an answer as an angle between what? Okay, so this is the non-calculator part. So you are doing this without the calculator, so you can't just take inverse sine of -1/3. So remember the angle, what does this mean? Theta equals, that means sine theta equals -1/3. But we restricted the domain of sine to have an inverse function. And so theta has to be between, for sine, it has to be between -pi/2 and pi/2, and you have to memorize that. That was the restricted domain for sine. So when we do sine inverse, we're going to get that. But because this is negative, which quadrant is sine? So here's -pi/2 to pi/2. Which quadrant for sine is negative? So you're going to get an angle between -pi/2 and 0. That's the kind of thing we want here. Not just knowing this, but knowing since it's a negative, you have to be in quadrant 4. Make sense? Okay. And then we're going to sketch a reference triangle and label all the sides and find cosine of sine inverse of 1 over x, section 4.7, right? Okay, so we start with the inside. The inside, we have theta equals sine inverse of 1 over x. Okay, and so then sine of theta equals 1 over x, and theta has to be between -pi/2 and pi/2. Sorry, I had to squeeze that in. All right, so let's just assume X is positive. Did it say, assume X is positive? It said X is positive up here, maybe that goes with this problem. I think that goes with this problem. We just figured out. It is part A and B, so X is positive. Okay, so we're in quadrant 1. So sine is opposite over hypotenuse. So this is going to be 1, and this is X. So I need to find, let's call this A. So A squared plus 1 squared equals X squared. So solving for solving for A squared equals X squared minus 1. A equals the square root of X squared minus 1. You can't, this does not simplify. That's it. This is the square root of X squared minus 1. So what is cosine of this? This is our angle theta. We now need to find cosine of theta. Cosine of theta. We draw on our triangle. Cosine of theta is adjacent over hypotenuse. And we don't have an X in the triangle. We don't have an X in it on the test, so it's going to be a number instead. Felt sorry for you guys. So. All right, and we'll start there next time, or if you have questions on, that was the non-calculated part.
Ah, goodness.